and here the acceleration is taken as plus or minus g. The direction, the sign indicates with respect to the direction. If the motion of the body is towards the gravitational, towards the surface of the earth, downwards. If a body is falling downwards, gravity is taken as plus g. If the body is moving away from the earth's gravitational pull, that is in the opposite direction, then the value of g is taken as minus g. And as usual, the time taken is taken. And the displacement, instead of the displacement as it is horizontal level, the displacement is considered as s. If it is in the case of vertical motion, the displacement is taken as h. So h be the displacement, the height attained by the body, the height or the distance traveled by the body with respect to height. So the first equation of motion will be changed according to So this equation of motion is now taken, the new form is taken as, instead of v, I should replace v as it is, u is replaced as u as it is, a should be replaced with plus or minus g into t. So with respect to gravity, the first equation of motion is transformed as v is equals to u plus or minus gt. And the second equation of motion is transformed as, instead of s, we should be writing h. So h is equals to ut half, okay, this a should be replaced with plus or minus g, this plus or minus g into t square. The third equation of motion is transformed as v square minus u square equals to 2. A should be replaced with plus or minus g, s is replaced with h. Whereas the fourth kinematic equation is replaced by hn is equals to u plus or minus, a is replaced with plus or minus g by 2 into 2n minus 1. Is that okay, children? So 2n minus 1. So if the body falls downwards, this value is taken as plus, and if the body is projected upwards, this value, acceleration due to gravity, is taken as minus g. And the case of freely falling body. So this is the equations of motion under gravity. If we would like to consider the equation of motion of under gravity for a freely falling body. So the third case. Equations of motion for a freely falling body. Here we go. Equation of motion for a freely falling body. Falling body. So freely falling means its initial velocity is considered as 0. So initial velocity of a freely falling body is generally taken as 0. Final velocity, it may attain certain velocity, so let us consider as v itself. Okay, and gravity, freely falling means the direction of the motion is downwards. Whenever the body is moving downwards, acceleration is taken as plus g. Okay, freely falling means downwards. So in that case, acceleration due to gravity is taken as plus g. And time taken to reach the ground is t and the distance covered be h. Then the first kinematic equation transforms as v is equals to u is 0 plus or minus gt, or simply v is equals to gt. And the second kinematic equation is transformed as h is equals to 0 plus or minus half gt square. It's nothing but h is equals to half gt square, not plus or minus, as it is falling downwards. As it is falling downwards, it should be taken only plus g. Okay, it should be taken only plus g. So v is equals to gt and h is equals to half gt square. Now the third kinematic equation is transformed as v square minus u square equals to, so 2gh, only plus symbol we need to consider. V square minus u square equals to 2gh, or v square equals to u square plus 2gh. And the fourth kinematic equation is hn is equals to g by 2 into 2n minus 1. Okay, children? So for a freely falling body, the four kinematic equations are transformed as v equals to gt, h is equals to half gt square, v square minus u square equals to 2gh, whereas h. So based on the above configurations, let us try to solve few numericals on this. Okay, children? So moving to the worksheet number 6 of kinematics. The first numericals is as follows. A body is falling under gravity. That means freely falling body. The distance covered in first, second and third second of its motion is. So you are asked to find out the distance covered in the first, second and third second of its motion. So here we go with first second. So third second, first second and second second is nth formula you will be using here. So coming to the nth formula for a freely falling body, hn is taken as g by 2 into 2n minus 1. So our formula is nth formula. Nth formula is nothing but g by 2 into 2n minus 1, the formula to be used for all aspects. The first case, for the very first case, the n value was given as first second, means n is taken as 1. For the second case, n is taken as 2, and for the third case, n is taken as 3. Okay. So case 1 for n is equals to 1, case 2 is for n is equals to 2, second session, and case 3 for n is equals to 3. These are the three different cases they have given. N equals to 1 second, second second, don't write 1 second, first second, second second and third second. Okay. Then the value of hn, that means h1, n is replaced with 1, is equals to g by 2 into 2 times of n is replaced with 1. 2 into 1 minus 1. 2 into 1 is 2, 2 minus 1 is 1. So g into 1 by 2 is g by 2, equation 1. The same for h2. So now replace n with 2. h2 is equals to g by 2 into 2 into n, replace it with 2. 2 into 2 minus 1 is nothing but g by 2 into 4 minus 1 is 3. Hence you have 3g by 2. Let this be second equation. Now moving to the third equation, h3 is equals to g by 2 into 2 into n is taken as 3 minus 1. This is nothing but g by 2. 3 to 6 minus 1 is 5g by 2. Equation number 3. Okay, so three distant distances we have considered, calculated, that is h1, h2 and h3. the distance covered in. So you have to find out the ratios of the three distances. Hence, the ratios of the three distances, that is the distance covered in first second to the distance covered in second second to the distance covered in third second, is g by 2 is to 3g by 2 is to 5g by 2. Okay, children. So this is nothing but you have 2, 2, 2 and G gets cancelled. Hence we have H1 is to H2 is to H3 is found to be 1 is to 3 is to 5. So your correct option would be first one. What is the value? 1 is to 3 is to 5 in SI system. If it FPS system, it is written as feet per second square. Okay, moving to the second question. A body released from a great height falls freely towards earth. Again, this is an example of a freely falling body. Another body is released from the same height exactly 1 second later. Suppose if the first body travels for x seconds, then the second body travels for hardly x minus 1 second, because it starts 1 second later. So if a body falls from certain height to the surface of the earth, if it takes 5 seconds, the second body would have taken only 4 seconds. If the first body takes 10 seconds, the second body would have taken only 9 seconds, 1 second lesser. Okay. The separation between both the bodies 2 seconds after the release of the second body is. So, you are asked to find the distance, separation between the two bodies. The first body would have covered certain length, certain distance. The second body would have travelled certain distance. There must be some gap between them after 2 seconds. You are asked to find out that gap, that distance between the two bodies. So, children, for this, what we consider is second. Okay, exactly this. 2 seconds later. 2 seconds later means the only formula you will be using is S is equals to, this is not nth formula, it is general formula, that is S is equals to UT plus half AT square is a generalized formula. But here in the case of equation of motion for a freely falling body, we have transformed the same equation for a freely falling body as Hn is equals to G by 2 into 2n minus 1. So, our formula would be, instead of S is equals to UT plus half AT square, we should replace, the equation should be H is equals to half GT square, not nth formula, generalized formula. H is equals to half GT square. So, because the freely falling body U is taken as 0, this is half, acceleration is plus GT square. This formula to be used for the two bodies. As I told you that if one body takes x seconds, the other body must take x minus 1 seconds. But here it was given that the second body, so you are asked to find the separation between the two bodies 2 seconds after the release of the second body. So from this we can make it out. So suppose if the second body travels for 2 seconds, then the first body will travel for 3 seconds, because it was given that 2 seconds after the release of second body. Let us consider the time taken for the second body. They have given you the time travel by the second body, it took 2 seconds. Okay, so that means first body would have started 1 second earlier, so the first body would have traveled for 3 seconds. Okay, so based on that, substitute for first body takes 3 seconds, whereas the second body takes 2 seconds, because it was already given after 2 seconds the release of the second body. So if second body would have taken 2 seconds, the first body would definitely take 3 seconds. So based on that, let us try to find out the distance traveled by the first body. For first body, let me mark it as sum 1, first case, okay? H1, so if you write it, you may get confused. First body like this, okay? What is the distance? May I write it as H1, just an indication? Okay, don't consider it as nth formula. Equals to half G. What is the time, children, given? It travels for 3 seconds. So that means 3 square is nothing but 9G by 2. The distance traveled by the first body in 3 seconds is 9G by 2. Whereas for the second case, the distance traveled by the second body will be half G. It traveled for 2 seconds, that is 2 square is nothing but 4G by 2, or you can also write it as 2G. Okay. Now we are asked to find the separation between both the bodies. Separation between both the bodies is nothing but the distance, the separation S is nothing but H1 minus H2. Okay, first body would have traveled larger distance, the second body would have traveled shorter distance. The gap between the two is nothing but H1 minus H2. What is this, children? Its value is equals to 9G by 2 minus 4G by 2. Nothing, 9 minus 4 is 5. That is 5G by 2. But here the values are given. We know that I have already given you the value of G as 9.8. So substituting in the above equation, 5 into 9.8 by 2. This goes by 4.9 times. So 4.9 into 5 is nothing but 9 5s 45, 5 4s 20, 24. Hence, the answer was found to be 24.5 meters. What is the answer, children? 24.5 meters. Okay. So the separation between the two bodies was found to be 24.5 meters. Okay. Option number 4. So moving to the next question, question number 3. A body dropped from a height h at a time t equals to 0. Again, dropped body. Dropped means freely falling body. That means initial velocity 0. So initial velocity 0 at an initial time t equals to 0 reaches the ground at a time t0. The time taken by which it would have reached. Here also we will be taking the generalized formula, that is S is equals to ut plus half. For a freely falling body, the distance traveled, I have considered it as h. Initial speed was 0. Freely falling means it is considered as 0. So this must be equals to half. Acceleration is plus g t square. The only formula we always use for a freely falling body. So body dropped from a height h, reaches the ground in time t0. The time taken at which would have reached a height h by 2 is, so clearly from this equation, if you would like to compare two equations, let me write it like this. H1 is equals to half. Half is always constant, G is always constant. Time taken, first case, let me write T1 square. Then H2 will be second case, that will be T2 square. If you divide these two, half of GG gets cancelled. Okay, children? So H1 by H2 is equals to T1 square by T2 square. This is the general concept, but the same thing can be worked out in another way. So children, let us try to find out here half is always constant, its value will never change and the value of G is 9 changes. From this equation, it is clear that the value of H always depends on time as t square. H is proportional to t square. If you would like to compare two different equations as it is proportional, H1 by H2 must be equals to, okay. That means, what does it exactly indicate? Means H1 is proportional to T1 square and H2 is proportional to T2 square. Okay, some constant into that. So for this case, we can write it as H1 by H2 is equals to T1 square by T2 square. So whenever this proportionality symbol occurs, like H proportion, others are constant, H proportional to T square, simply write it as comparison means H1 by H2 equals to T1 square by T2 square. That's it. What is the value of H1? First height was given as H. Second height was given as H by 2 equals to first time was given as T0 square, T0. So T0 square, and second time unknown. So this H and this H gets cancelled. This 2 goes upwards. Then we have 2 is equals to T0 square upon T2 square. Okay, children? So 2 is equals to T0 square upon T2 square. You are asked to find out the time taken which have reached this height with T2 you are asked to find out. So interchanging the terms, bring the T2 here and the 2 here. So just let us interchange the two terms. We have T2 square will be equals to T0 square by 2. Just exchange the terms here to there and there to here. Hence, the value of T2 would be square means all the squares. T2 means you have to take the square root of this. Square root of T2 square is T2. Square root of T0 square is T0. Square root of 2 is, hence, the relation, the new value, time taken to reach height H by 2 is T0 by root 2. Here goes your answer, third option. Okay, children? Moving ahead, next question. Fourth, a body is dropped from a building of height 1500 meters. After 2 seconds, another body is dropped from the same point. Okay, two different bodies. Here, one body was dropped from 1500 meters height. Another body was dropped from the same point. The height was common, but only the time taken, time interval is different. How long after the first body to fall, the two bodies be 120 meters apart? It's a little bit similar to the second numerical. Okay, let us see. So clearly it was given that the total height was given as 1500 meters. And the first body would have reached a certain distance, whereas the second body would have reached another distance. The distance between these two was given as 120 meters. Okay. And only thing is that the time is different, and the value of G, children, generally the value of G is 9.8 meter per second square. For approximation, 9.8, if you make it round figure, approximately it can be taken as 10. Okay, few cases we will be taking the value of G. So, instead of 9.8, sometimes for making the numerical easier, so we will be considering the value of G as 10 meter per second square. So don't get confused as they have given you. So no doubt you can substitute the same. In exams also they will be giving you to consider the value of G as 10. Then only you will be considering. If not, the value of G is always 9.8 meter per second square. Okay, so this is again a freely falling body. As we know that for a freely falling body, the condition is S is equals to UT plus half AT square. S is equals to UT plus half AT square is the generalized equation, but for a freely falling body, S is generally denoted as H, and initially it is freely falling means initial velocity is 0, half acceleration is G, GT square is your formula. So H is equals to half GT square. If it travels for T seconds, the second body have dropped after 2 seconds. So if takes T seconds means the second body travels only for 2 seconds lesser than the T minus 2. If the first body 10 seconds, second body 8 seconds. First body 5 seconds, second body 3 seconds. First body X seconds, second body X minus 2 seconds. First body N seconds, second body N minus 2 seconds. So 2 seconds lesser. Okay. So now the distance travelled by the first body, instead of h, I have considered some distance travelled by the first body as s1 or else h1 also you can consider, your wish. So the distance travelled by the first body is half gn square. Time I have considered as n instead of t. Okay, distance also I consider admitted as s1. For the second body, if you consider s2, the distance travelled by the second body will be half g. It was dropped 2 seconds later on. So that means n minus 2 whole square. But what is the given condition? How long after the first body? How long means time. Okay, you are asked to find out time. The two bodies be 120 meters apart. You are given that the difference between that, the distance between first body and second body is 120. Okay, the gap between the first body and second body was given as 120. If this is the condition, what is the value of n? So this is your question. So let us try substituting the same, children. So s1 instead of s1, half gn square. s2 means half g n minus 2 whole square. Okay, n minus 2 whole square equals to 120. So try to solve this, children. What is your getting? Half g n square minus n minus 2, half g, keep it here. A minus b whole square can be written as a square minus 2ab plus b square. A square means n square minus 2ab, 2 into n into 2, that is 4n, plus b square plus 2 square, that is 4 whole square is 120. Okay, children. So now based on that, let us try to solve the same. Maybe the place is not sufficient. Okay. So taking this inside, how much you'll be getting? Half g n square. This minus half g into n square is minus half g n square. Minus half g into minus 4n is minus will become plus. Half into 4 is 2. So this will be plus, minus is plus, half into 4 is 2, and there was left g, here was left n, 2gn. Again this minus and plus will become minus, half into 4 is okay. Well, half into 4 is 2g equals to 120. Is that okay, children? Half gn square minus half gn square gets cancelled. So you're asked to find the value of n. So 2gn minus 2g equals to 120, but the value of g was given as 10. So let us try to substitute the value of g. So 2 into 10 into n minus 2 into 10 equals to 120. So that is 20, n was found to be 2 into 10 is 20 minus 20. If it is taken, it will become 140. Hence the value of n is 7 seconds. Is that okay, children? So from the equation h equals to half gt square. For n seconds, half gn square, because 2 seconds later the second body was released, n minus 2 whole square. And the separation between the two bodies was given as 120 meters. So s1 minus s2 was taken as 120 meters. So s1 instead of s1 I substituted the value, instead of s2 I substituted this value. So safely, properly taking the symbols under consideration. Okay, then try solving the numerical and then later substituting the value of g, you get the value of n as 7 seconds. Your answer is option number 2. Okay, well, moving to the next question. A person sitting on the top top of a tall building is dropping balls at regular intervals of 1 second. So first ball was dropped. After 1 second, the second body was released. After 1 second, again third ball is released. Again after 1 second, fourth ball is released. Like that, after every fraction of second, he is releasing ball. Okay. So what are the positions of the third, fourth and fifth ball respectively when the sixth ball is being dropped? For this, let us consider a small picture. So totally, first ball was released, second ball was released, third ball, fourth ball, fifth ball, and he is about to release the sixth ball. Okay children,